Alright, so what we're going to be looking at now is that we're going to be looking at the second half of this section, which deals with solving three variables but with substitution method instead of the elimination method. Again, this one you're going to have to make sure you have a lot of paper and make sure you can keep track of everything, because there is going to be a lot of things that you're going to be plugging back into. So remember, the substitution method, you'll solve for a variable and then plug it in to another equation for that variable. Okay, so this is the substitution method. Alright, so let's say we have this right here. So what I'm going to do is I'm going to start with the top one and I'm going to solve for x. Giving me x is equal to, so move everything to the other side, 6 plus 3y minus z. Okay, and that's how you're going to start. You're going to solve for one of the variables, whichever variable it is. Now, once you have that, you're going to take that x and plug it in for the x of another equation. So I'm going to plug it into the second one. So it's going to be 2 times 6 plus 3y plus z, or minus z, that is the x that's being plugged in, minus 5y minus z equals negative 2. Distribute the 2 and then simplify everything. After I distribute it and I simplify, okay, I end up getting 12 plus y minus 3z is equal to negative 2. Now I'm going to solve for y, so I'm going to move the x, or the z and the coefficient to the other side, and that gives me y is equal to 3z minus 14. Okay, and what we're trying to do here with the substitution method is get everything in terms of one variable. So now what you can do is you can take, see what this y equals is 3z minus 14. You can take that and plug it in here for that y. So you have x is equal to 6 plus 3 times 3y minus 14 minus z, oh no, 3z minus 14 minus z. Distribute everything, we get 6 plus 9 y minus 12, oh no, not minus 12, minus 42 minus z, and now we end up getting x is equal to, oh, this is z, not y, z, looks like 8z minus 36 approximately. Okay, and so yeah, and so now that's what we have. So for the last one, we're going to take our last equation, okay, and we're going to substitute in for the variables what we have for z's. So I'm going to use this equation and substitute it in for the x and y and solve for z. So I'm going to have negative 8z plus 36 plus 3z minus 14, here's my y, here's my x, plus 2z is equal to 7. Combine like terms, that gives me a negative 3z plus 22 is equal to 7. And when we simplify, we get negative 3z is equal to negative 15, which means that z is equal to 5. So z is equal to 5. Now we take this z, and we're going to plug it in for the z's in the other two equations. So for my y, I've got y is equal to 3 times 5 minus 14, which means y must be 1. And then for the other one, x is equal to 8 times 5 minus 36, which means x is 4. So that means my answer would be 4, 1, 5. So when I plug in a 4 for the x, a 1 for the y, and a 5 for the z, all three of those equations will come up true. Okay, and that's substitution method. All right, so again, it's messy. There's a lot of things going on, and you've got to keep track of everything. Okay, now for the next one, what I'm going to do is I'm going to start with the top and I'm going to solve for z. So I get z is equal to 3x plus 2y minus 12. Okay, so I just moved the z over and then I moved the 12 back. This is being plugged into the third equation in for the z. Okay, so I'm plugging it in here. And so I have x minus 3y. I want to box this so I know where it's at. Minus 4y plus 3x plus 2y minus 12 is equal to negative 4. Simplify, combine everything, I get 4x minus y minus 12 is equal to negative 4. Solve for y, I get y is equal to 4x minus 8. Okay, and now I'm going to box this one. I'm going to take this and plug it in for that y. And so my z becomes, z is equal to 11x minus 28. Okay, so I just plugged the 4x minus 8 into the 2, so that got me 3x plus 8x minus 16 minus 12. Okay, and now I'm going to box this one. Okay, so now I'm going to take those two and I'm going to plug it into the equation I haven't used yet. Okay, so I've used this equation, that was my first one, and I used this equation, that was my second. So now I'm going to use the last one. So I have negative 4x plus, it's going to be 2 so I'm going to be using this equation. So it'll be negative 4x plus 4x minus 8, which is my y. This whole thing was y, minus 2 times my z, which is 11x minus 28. Okay, and that's this one here, the z. And that equals 4. Now I distribute, simplify everything. I get down to a negative 8 minus 22x plus 56 is equal to 4, getting me negative 22x is equal to a negative 44, which means that x equals 2. Now I take this 2, and I plug it in here, giving me y is equal to 0, and I take this 2 and plug it in up here, getting me z is equal to a negative 6. So my answer would be 2, 0, negative 6. And as you see, those will always work out. All right. So that's the substitution method. So again, it takes a lot of work making sure you've got to keep track of everything. All right. But you just substitute in, substitute in, substitute in. All right, here's your IRAT. What I need you to do is I need you to solve this both using elimination and substitution. So do the one you're going to feel more comfortable with, do it that way, and then try the other method just to make sure you can get, and you should have the same answer for both of them. So do both the elimination and substitution for this problem. All right.